So let's see the chemical reactions of alcohols and phenols. So as we know, alcohols are versatile compounds. They can both act as nucleophiles and electrophiles. So if it is act as a nucleophile, there is OH bond is broken. And if it is act as an electrophile, the carbon and oxygen bond will break. We know alcohol are the compound which contain OH functional group. So there is a direct bond between oxygen and hydrogen and carbon and oxygen. So if you check the reactions, if it is act as a nucleophile, the OH bond will break. Here you can see the OH bond will break. In the case of it is act as an electrophile, then the carbon and oxygen bond will break. So let's see the reactions. If you check here, if alcohol acts as a nucleophile, you can see here the OH bond is breaking here. Here you can check the OH bond will break. And if it is act as an electrophile, the first step is the protonation of alcohols. That is, protonation means addition of hydrogen. So if you check here, the carbon and oxygen bond will breaking. In the second step, you can see the carbon and oxygen bond will break. So let's see the examples one by one. So in the reactions involving cleavage of OH bond, there are different type of reactions. It is based on the acidity of alcohols and phenols that we discussed earlier about the acidity. So in reactions involving cleavage of OH bond, the first type is reaction with metals. So we know the metals, alcohols readily react with the active metals such as sodium, potassium, aluminium, etc. Even phenols also will undergo the same reaction. They will also react with sodium, potassium and aluminium such as active metals, and they will form alkoxide and phenoxide. So what is alkoxide and phenoxide? Let's check the reaction. Here you can see alcohol react with sodium which give alkoxide. Alkoxide are the compound which having direct metal and oxygen bond containing compounds are known as alkoxide. Here you can see oxygen is directly attached to the sodium. There is a direct bond between oxygen and sodium. Such compounds are known as alkoxide. So if it is sodium, so sodium alkoxide. If it is aluminium, aluminium alkoxide. If it is potassium, it is potassium alkoxide. So if you check here, you can see that if it is reactive with the sodium, the OH bond will break, the hydrogen will leave and sodium will attach here. If you can see the reaction. So alcohol react with sodium which will give sodium alkoxide. For example, here you can see tertiary butyl alcohol. If tertiary butyl alcohol react with aluminium, it will form aluminium tertiary butoxide. Aluminium tertiary butoxide plus hydrogen. This hydrogen eliminating from here will be there. So 6 hydrogen will be eliminated. So 6 hydrogen will get. How many hydrogen will eliminate from here? That much hydrogen will produce there. Similarly, if check with phenol, phenol directly attached with sodium, the hydrogen will leave. Similar to alcohol reaction, if you check here, hydrogen will leave from here, sodium will attach to here. So we'll get sodium phenoxide. So this is the first type of reaction. If alcohol and phenol react with active metals, they will form the phenoxide of that metal. If it is aluminium, it will form aluminium phenoxide. If it is potassium, it will form potassium phenoxide. Then we discussed about the acidity of alcohol and phenol. The next type of reaction is the esterification reaction. So what are the esters? Esters are the compound which contain OC double bond O R dash bond. OC double bond O R bond. We are using so many esters in our daily life. The esters are using to give a smell. We know we are using esters as biryani essence. In biryani, there is a pineapple essence. which will give a very fruity smell, that is an ester. And we are using esters in perfumes. So esters are a very important compound. So if we check, the alcohols and phenols have the ability to form esters in the presence of, if it is reactive with carboxylic acid or acid chlorides or an acid anhydrous to form esters. So if you check, both alcohol and phenol will form esters. So let's check one by one. So if it is alcohol, either alcohol or phenol, if it is AR, it is denoting phenol. If it is R, that is alcohol. So if it is reactive with carboxylic acid, what will happen is, it is a protonation reaction again, protonation. So here we can see that this hydrogen of alcohol and OH of our acid will combine and form H2O. Then either further groups all attached together. For example, you can see here RO, CO, CO, R dash. This much portion will attacking here, is attached here. You can see that here you can see the reaction and the elimination of hydrogen from this, hydrogen from alcohol and OH from our acid and form RCH2O, and all other group will join together. This is in the same case of our phenol. And if it is act as active with acid chlorides, the reaction also similar. You can see that we'll get ester, and hydrogen from alcohol and Cl from our acid chloride will eliminate and form HCl. So it is a protonation reaction. It will occur in the presence of concentrated sulfuric acid or concentrated sulfuric acid, and this reaction is reversible. So what if we seen here that H2O is eliminating, if it is reversing occurring, what will happen? The H2O is again added to this, will get back the alcohol and acid from the esters. So it is a reversible reaction. So in the acid chlorides reaction is in the presence of a base. So we can see here a reaction. For example, here you can see another reaction of this. We'll get acetyl salicylic acid. It's a form of ester. Then there are the reaction involving cleavage of carbon and oxygen bond. That is CO bond. So it is only occurs in alcohols. So in phenols, if it is react with zinc only, the CO bond breaking reaction will occurs. In that, the first type is reaction with hydrogen halides. What are hydrogen halides? Hydrogen halides are the compound which contain hydrogen and halogen. For example, this X may be fluorine, chlorine, bromine, iodine. So in this reaction is, you can see here ROH reacted with HX will, what will happen? We know OH is a good leaving group, so OH will leave and halogen will add to here, and the formation of H2O. The leaving OH plus hydrogen from the halogen halides will form H2O. It is a, we can call this, it's a replacement reaction or displacement reaction or substitution reaction. Okay, this is a type of substitution reaction. And next type is a very important reaction called Lucas test. It is a reaction for the distinction between primary alcohol, secondary alcohol and tertiary alcohol. There is a Lucas reagent. Lucas reagent is concentrated HCl and zinc chloride. This zinc chloride in concentrated HCl. If it is their halides are turbid, so it is produce a turbidity in solution if it is reacted with, if alcohols are reacted with Lucas reagent, it will form the turbidity. So based on this turbidity, we can identify whether it is a primary alcohol, secondary alcohol and tertiary alcohol. So if you take tertiary alcohol in the presence of Lucas reagent, what will happen is if we add Lucas reagent to tertiary alcohol, if we don't know, there are three alcohols are given. We don't know which is primary, we don't know which is secondary, we don't know which is tertiary. So what we can do, we can take this as a test. In that test, we can see if we add Lucas reagent to one test tube, if it is forming turbidity suddenly, that is a tertiary alcohol. Tertiary alcohol will give sudden turbidity when it is reacted with Lucas reagent. And if secondary will give turbidity in a few minutes, and primary alcohols do not produce turbidity at room temperature. So we can easily identify the primary, secondary and tertiary alcohol by using Lucas reagent. If it is giving sudden turbidity, we can call it as tertiary alcohol. If the turbidity is forming after some time, that is secondary. Primary alcohol will not give turbidity while reacting with Lucas reagent. So it is a distinguishing test between primary, secondary and tertiary alcohol. The next type of reaction is dehydration reaction. What is dehydration? Removal of water. If removal of water which give form alkenes on treating with protic acid. Protic acid means acids which have the ability to donate hydrogen. So concentrated H2SO4, H3PO4 are using, that is sulfuric acid and phosphoric acid are used as in the reaction, or catalysts such as anhydrous zinc chloride or alumina we can use. So in the reaction, we can see the example. We know in the reaction there is elimination of water occurring. Here you can see an alcohol. If alcohol is reacted with protic acid, H2SO4, H3PO4, zinc chloride, etc., we can use as catalyst here, reactants here. So in the presence of acid and heat, it will the HOH, the H2O will eliminate here. So the bond will shift to here. We'll get alkene. For example, here you can see a reaction. Here you can see the formation of alkene. So we need in a this also we can identify the primary, secondary, tertiary. The primary alcohols need a very concentrated acid, but in the case of secondary and tertiary alcohols, the dehydration will occur in milder conditions. We did not need strong acids. We can use 85% of phosphoric acid, etc. Here also there is a formation of alkene. Here also, if the secondary and the tertiary, also the formation of alkene. So the ease of dehydration of alcohols follows the order. Tertiary will undergo dehydration very easily, then secondary, then primary. Why? Because the bulkiness, we know here 3 CH3 bond is there. So it is easy. So the utility effect will be more. So it is very easy to remove H2O from here. But here only single bond. So it is difficult to remove OH and hydrogen to form water. So there is a reason, the bulkiness of the compound. So we can see the mechanism. First is formation of protonated alcohol. First is the formation of protonated alcohol, and the second step is formation of carbocation. We all studied this in the last chapter in the elimination reaction type. We have studied this. So the first step is formation of protonated alcohol. Second step is formation of carbocation. Third step is formation of ethene. For example, if we check here, protonation, first step is protonated alcohol. If we know it is reacting with H2SO4 such as, so it will give H plus, so that protonated will get protonated alcohol. The second step is the protonated alcohol will eliminate from here and form carbocation, and the dehydration will occurs. will get alkene.